course, I always choose rush hour to record the podcast. Wow, I've just climbed out of a science, I hate to use the word rabbit hole, but yep, a science rabbit hole, learning about synthetic diamonds. That's what I'm going to call them, synthetic diamonds. In the last episode, I was calling them manufactured diamonds, but I think today let's call them synthetic diamonds. And these are diamonds made in a machine, not found naturally in the ground. So today's episode is about synthetic diamonds, how they're made, and what the deal is with them compared to natural diamonds. This is a show about jewelry, why we wear it, why it matters, how it's made, and what it means. I'm Alex D, and I turn cannabis into gold. I make mind-blowing jewelry in gold, silver, and platinum from cannabis plants here in Canada for stage, screen, for people who want to rock crazy jewelry. I'm the cannabis goldsmith. So I started doing research for this show at the end of the last show, and I'm still doing it. It's like this topic is so deep that I started off looking into synthetic diamonds for jewelry purposes, but I got waylaid by making diamonds for industrial purposes because I really had no idea what they do with diamonds or what good are they in an industrial sense. So for you jewelers wondering what the hell that's about, this will be a little about that, this show. So you'll be able to understand the other applications of diamonds and of synthetic diamonds. And I was like marooned in this kind of whirlpool of like science. And believe me, I don't understand science all that much. So I could have relied on other journalists who actually know more about science, who studied the material, but instead I went looking for the material myself and started reading these technical papers on how they manufacture diamonds. So in 1892, a French chemist named Henri Moissan theorized that you could create diamonds if you replicated the natural processes of the earth. So we thought, okay, diamonds formed in the molten rock and pressure, and how would they form in that environment in the earth? And he said, well, he theorized that if we could replicate this in an experiment or in a controlled way, we could replicate diamonds. It's just that you don't want to wait like a million years to get your diamond out of that. Time is also a factor. If you recognize his name, Mr. Henri Moissan, moissanite. He also invented moissanite a little bit later on. But the whole idea of growing diamonds, laboratory-grown diamonds, to grow them in a vat, but inside the vat is the replica of the Earth's kind of inside the Earth's mantle or crust, what's going on there. So that was his idea. But today's show, I'm going to sort of try and describe how they make these diamonds and why they're different than natural diamonds in some ways and why they're the same in some ways. So here we go. I'm a bit late getting it together today because I got so into the rabbit hole of this science shit. It's just like crazy. I haven't gotten this deep into science in a long time, and it's really, I'm finding it fascinating. Like, I decided to go for the source. Like, instead of talking to journalists about this, I decided to read papers, go and look at original papers and industrial papers and stuff. And that's where I was lost this morning. So there's going to be a bit of background noise of traffic here today. I'm a bit late and right in rush hour. You'll get some good, what do they call it? Atmosphere. Okay, here we go. There are two ways that they're making diamonds these days. that they're synthesizing diamonds. There's two processes. Let's get the boring stuff out of the way first. There are two ways that they are manufacturing or synthesizing diamonds today. There's the CVD process and the HPHT process. Now, you're going to forget all this like I will in about 2 minutes. But there are some differences. Okay, the CVD process, it's like painting a wall with spray paint. They get a seed diamond, which is the wall, and then a carbon-containing gas, which is like the spray paint. And lasers or microwaves are like the nozzle that breaks down the paint into tiny droplets. And the droplets then stick to the wall when you're spraying the wall, forming a thin layer of paint or diamond on seed or wall. And this process is repeated until they get a thickness of paint that they want, or a thickness of diamond that they want. So that's the CVD process, like painting a wall with spray paint. Now the HPHT process is different. It's like making candy from sugar. The diamond seed is like the mold, the candy mold. And the graphite and metal mixture is like the sugar and water solution. So they melt it all together. And the HPHT press is like the stove that heats everything up to a high temperature. The sugar dissolves in the water and then crystallizes in the mold, forming candy or a diamond. And this process is repeated and repeated until the desired size of candy is achieved. But it's not a million years, thankfully. They've got it down to days per carat. And I think there are rules of thumb around how many days it takes nowadays to make a carat in each method. So these are the CVD is like spray paint, and then the HPHT is like making candy. I guess, why is any of this like important? Well, for jeweler, I mean, it's not, but I guess, you think of cuts, you're dealing with cut stones or raw stones you want to achieve an effect with. Today, a lot of the diamonds you can get are synthetic diamonds on the market, and they're created by either one of these two types of processes, a CVD process or the HPHT process, the spray paint or candy process. So what's better? Well, that's not an easy question to answer. I thought that the one process was used more for industrial and the other was used more for jewelry, but that's not the case. It's mixed. There are different factories in different parts of the world using these presses to press diamonds and using these methods. As recently as last month, the IGI, the International Gemological Institute, analyzed and graded a 50-carat diamond produced by the CVD method. This is the method I thought was going to be mostly for industrial use. That's the spray paint method. But that's massive. That's 50 carats, named the Shirpa diamond. And this was produced by Ethereal Green Diamond in Mumbai. Now, so in 50 years, we've come from 0 carats to 50 carats. In the early 70s, GE started producing kind of small gem-grade synthetic diamonds, and like tiny, tiny ones. And now we're at 50 carats. So you can see where it's going. They'll soon be like I said last week, that everyone will be having these big, massive stones. But it's still not like we're still not where they're coming out of bubblegum machines now, man. It takes 6 months. It took 6 months to produce that 50 carat stone in the press. Imagine the energy and the power and all that stuff on full blast for 6 months to produce that magnificent synthetic stone. But you can see where it's going. But during the research for this, I'm still doing the research now because I'm finding it so interesting. The what I learned about the CVD diamonds, the spray paint method, it has this ability to produce these flat crystals, diamond crystals that are really, really good quality optically. Now, I discovered that diamonds have these huge there's stuff going on with diamonds. Why everyone wants to use them nowadays is because of their optical properties. And it's even more than optical properties. Like, I'm not a physicist either. God, I never even got to a physics class, I don't think. But, or I've forgotten them totally. But the idea of think of it as eyeglasses and sunglasses. So if you're walking around your whole life with really dark, like with a welding mask on, right? That you're seeing everything in this sort of color, this sort of gray color or whatever. And that's your spectrum. That's all you can see, right? This is what most materials like Gorilla Glass or regular glass, or even better, sapphire, something that has that's really transparent, right? A crystal like sapphire. It's still like wearing a welding helmet. You're missing all the other stuff going on. As soon as you take the welding helmet off, you can see, oh my God, look how bright everything is. Look at all this stuff that I couldn't even see before because I had this stupid welding helmet on. This is transmission, right? Optical transmission. And this is, it even goes beyond optical. Like, I was looking at this chart. There's this one chart I saw where it compares the properties of diamond to the properties of Gorilla Glass, like on phones, right? And then it showed another little area where the human, what humans can see, right? The human, what we can see is like, it's this narrow little kind of slice. And then the Gorilla Glass stuff that can go through Gorilla Glass is like way wider than that. And then sapphire is wider, than you can allow more spectrum through that. But diamond covers everything, like everything from like ultraviolet, infrared, radio waves. Everything seems to pass right through it. Like, this is what I seem to gather from reading all these technical papers. Like, what this means from an industrial perspective is that, okay, take the welding helmet off, man. Like, if you want to send light from one thing to another without anything getting in the way, you use a lens made of diamond, right? Because otherwise anything else is not as clear, can't transmit what's going into it in the bandwidth that diamond can do, right? That diamond can transmit. It's like a clear window instead of a welding helmet on your head. It allows for this range of spectrum to go through the stone. I had no idea. You know, when I think of optics, like, I'm a photographer, I think, okay, I have a camera, I take, you can create these effects. Any first-year photography student will get like a pane of glass and rub Vaseline on it and try and shoot photographs through it to get these groovy like effects, that their teachers have seen, God, forever. But this is how we are all seeing the world, right? We're seeing the world through glass that's covered in Vaseline, and then when you clear all that off, you have like a diamond, and the diamond allows this transmission of things better. So immediately I could see how they could be using this shit. Like, everything these days is lasers and fiber optics. You could see how this could be used for precision laser stuff, because the beam would not be affected. What you put in one end coming out the other would be pretty much identical. And all the stuff that we can't even see, like microwaves and all that, it can pass right through that too, right? Like through diamond as a lens. Industrial applications are like huge. And The thing is with lenses, like I'm just a photographer. So if you're a physicist or whatever and you think I'm going about this the wrong way, send me an email and I'll make a correction. But as a photographer, the way I think about lenses, right? The clearer they are, the better, and the sharper they are, the better. And if you have a diamond crystal that's perfectly that's invisible to whatever you're pumping through it, it's going to be, you know, what you get in the end will be way better, right? So the industrial uses of these synthetic diamond lenses or whatever, you can just like imagine them cutting silicon chips, right? Cutting CPU chips out of silicone or making dies or shit, like really small, like engraving or however they do it. I have no idea, but I'm sure these synthetic diamonds come into play somehow in the machinery that allows them to do that, or like really small, tiny work, because these stones can transmit everything, whether it's laser beams or microwaves or light or whatever. So that I thought was incredibly cool. But the other thing is with the CVD process, the spray paint process, you can see now where it comes into play, where you can add layer after layer over time, right? You just keep spraying layers on. You get this nice thick layer of diamond that you can form into a lens and use in your application, right? Now the thing is with this, like as technology gets Moore's law, like we're on this treadmill moving into the future. Doesn't it feel like that every single day there's like AI or some other shit coming at us full blast and changing what we once thought was unchangeable forever, in fact, right? But diamonds now can be made in machines like an easy bake diamond oven, right? Like, let's put some molten metal, some graphite, give it 6 months, and we'll come out with a 50 carat diamond, right? Let's add a little bit of this in there. We'll throw some of that, a little bit of this, a little bit of that, and we'll come out with a nice rainbow colored diamond, or a gold colored diamond, or a pink diamond. Or they can create recipes now for what they want to achieve at the end, right? In this manufacturing process. It's getting so that these stones, they know how to do it now. And it's just a question on how big and how many they can make. So what's happened, and this relates to last week's show, is where are the diamonds being made? Where are these diamonds being made in the world? Now, the United States, GE, of course, invented this process of doing it, but now it's happening everywhere, and it's happening a lot in China. I would think, from what I've researched, that China is the world leader in this now. In the same way that in China there would be entire towns making tube socks, there's an entire region manufacturing diamonds for industrial use and for gem grade. And this area of China is positioned very close to all the resources they need. And Russia is one of the largest miners of diamonds in the world, but they're also a massive manufacturer of synthetic diamonds. Here we have all these advantages of using diamonds industrially. We have these places in the world that are being set up now to manufacture diamonds at scale. This area, the tube sock town mentality, focusing an entire geographic region on the production of diamonds, industrial or jewelry diamonds. The other thing I learned about while researching all this stuff is you have to think about diamonds are so hard that you need other diamonds to do anything with them, right? So you basically need twice as much as the finished thing, whatever it is, in whatever industry, or jewelry or whatever. You probably even need more than twice as much, because you need the finished diamond that you want to use in your application, whether it's in your ring or as a lens in your fiber optic satellite thingy or whatever. But in order to polish the diamond to the degree that you can use it, you have to use all these other diamonds. So there's a huge market for diamonds as tools, as diamonds as final purpose goes forward in time. So I think the diamond trade is going to be changing more from a jewelry thing to an industrial thing. It becomes much harder to market something that's super high end in a world where everyone is able to provide it for 40% less, 60% less. Everyone is able to provide similar objects at a fraction of the cost that are exactly the same, unless you have a special machine to tell them apart. Now this is going to come really hard for the jewelry people. But there's also a side. The thing is with these synthetics, I'm looking at the industrial applications here are going to be huge. But these are different kinds of diamonds. This is not story. These are not diamonds whose value is inflated with story, like advertising or marketing campaigns. These are diamonds that actually perform in a job or task, right? So the amount of money that can be charged is relevant to the task and not the per carat weight of stone or how long it takes to produce. That's what I think. So the industrial thing is super interesting, and that's where I was lost this morning in diamonds. These lenses for whatever they're using them for, medical applications, containers for stuff. Just so interesting. But anyway, the jewelry is going to be in for a shock. That's what I think. Because as they are able to produce more and more different types of diamonds at scale. I said last week that a machine was probably just producing these things and automating them and cutting them and sorting them and all that stuff. It's all being done already. It's all being done. But imagine making diamonds to suit. One of these areas in China could produce a diamond for, say, a maker. But say a jeweler around the world who wanted a certain color diamond that's not available in nature, they could make it to suit, build it, create it, grow it to suit the application. That's for extreme high-end stuff. But the other implication with this is that I keep hearing that the younger people today, the younger generations today, are more interested in the environment and climate and this kind of stuff because, frankly, we've destroyed everything and they're stuck with it. And they need to be concerned about it, I think. The idea that you don't have to send kids into the ground to dig stones out to be sold in jewelry stores in North America or Europe, that's I think the younger generations today understand that. They're not fooled by the marketing. They understand that they would rather, if they're going to have a diamond, they might as well have it made in a factory that's not doing that to people, right? Or the land or whatever. So I understand that clearly, and that is going to be a huge force to be reckoned with in the jewelry diamond industry. Already the jewelry diamond synthesizers makers are stressing this, and so they should. It's okay, these diamonds come from a machine, not from some horrible like thing, right? So you can know where it comes from. Or you can just buy a Canadian diamond that is mined in Canada and produced under the best conditions possible. These are going to be the choices. There's going to be a huge glut of sort of the diamonds in the middle that are mined but facing a decreasing, their value decreases each day as the amount and quality of synthetic diamonds increases. There's going to be a lot of stuff going on with diamonds going forward. I just know it. It's going to be interesting to watch. But now I'm going to keep, after doing all this research on diamonds, synthetic diamonds in industry, I'm going to keep my eyes peeled for more stories. These are stories easy to miss. Like, you don't even hear about them, like diamonds and satellites, or it's not just in James Bond movies. It's actually, they're actually doing this shit, right? It's like, wow, that's cool. So I'm keeping my ear to the ground, my nose to the grindstone, and I'm going to keep my eye on synthetic diamonds. They are real diamonds. They are actually diamonds, and they are the future, I think. Now, it might be wise to think of these diamond manufacturers as mines. Think of them as mines. So, or all of the ones clustered in China in this geographic area. Think of it as a mining region. The new form of mining for diamonds. We're not going underground anymore. We're going into the factory to make them, to press them. The easy bake diamond oven, under high pressure with lasers and microwaves, heating everything up. Let's just pump them out. Cookie cutter. Get them out there, into the market. Now, for industrial use, this is great because you want consistency, but in the way of jewelry diamonds, I'm not so sure. I think the inconsistency is going to be where the old money will stay anyway. But there's going to be some interesting stuff happening with manufactured diamonds. Anyway, that's it for me. Sorry for the delay this week. I got lost in this damn science rabbit hole. I normally don't think about science, but when I do, it's really damn interesting. I'm going to put some links in the show notes here to where you can get good, solid, honest information on synthetic diamonds and how they differ from real diamonds. And I'll see you next week. I don't know what I'm going to talk about next week, but I'll figure it out. The Cannabis Goldsmith is produced by Tribe Communications, Inc. in the Thousand Islands area of Ontario, Canada. You can see what we do at tribe.ca. Send us an email, alexd@cannabisgoldsmith.com. Thanks for listening, and we'll see you next week on the Cannabis Goldsmith.